Hey guys, this is Mr. Drabinski, and today we're going to talk about Lesson 11, which is solving quadratic equations by factoring when a is equal to 1. So let's go back, before we start talking about this, let's go back and kind of revisit the last lesson. In the last lesson we talked about solving quadratic equations that had the form ax squared plus c, so there was no middle linear term, there was no bx term. And what we did here is we solved for x by using the square root. So as a quick example, we could take something like 2x squared minus 6 equal to 2. We can add 6 to both sides. 2x squared is equal to 6 plus 2 is 8 divided by 2. So x squared is 8 divided by 2 is 4, and then this is where we got to use square roots to undo the square. So the square root of 4 is going to be 2, plus or minus, because both negative 2 times negative 2 and positive 2 times positive 2 is going to be 4. So in this case the solution is plus or minus 2. Oftentimes you could have a decimal, and then you'd have to simplify the square root. So this was the previous lesson. In this lesson, we're going to talk about a trinomial. So trinomial is 3 terms. When the first term is 1. So in other words, it can have the form x squared or 1x squared plus some number bx plus some constant. Here's an example that we're going to do in a little bit. So we're going to talk about x squared minus 7x plus 10 equal to 0. And the idea is to find what value can I plug in for x, and it has to be the same one in both places. What value or multiple values can I put in order to get an answer of 0? So let's first talk about kind of a less effective way to do it. And one maybe less effective way is to just guess a number. We could say, for example, well, 1 is a possible solution, so that we can plug it in. So we can take this trinomial and we can say, well, what happens if x is 1? It's going to be 1 squared minus 7 times 1 plus 10. So simplifying this down, 1 squared, 1 times 1 is 1, minus 7 times 1, 7, plus 10. 1 minus 7 is negative 6, plus 10 is going to be positive 4, if my mental math is correct. But we could see in the equation we were expecting to have an answer of 0. So we know that 1 is not a correct solution to this. And we could try more and more numbers until we get something that would give you 0 when you plugged it in. So that's not as effective, especially when the numbers get bigger or more negative. So one more effective way we could do this is a strategy called factoring. One way to solve the quadratic equation is to factor it and then apply the zero product property, which is what we discussed in the pre-lesson 11. Factoring means breaking something down into the things that make it by multiplication. So for example, I could say the factors of 10 are 5 and 2, because 5 times 2 builds the 10. So when you factor, what you're essentially doing is you're looking for, the key here is the same numbers. You're looking for the same numbers that do both things. You want to multiply to get c, which means multiply to get the last number, and then you want to add those same factors in order to get b. And one kind of way at first when you're learning this is to set up what's called a t-chart, which looks like this. So you can draw kind of a T, and then you would put factors of c. So this example here, factors of c. In other words, you're looking for what multiplies to 10, and at the same time it has to add, or in this case subtract because it's negative, subtract to negative 7. So one possibility, switch pens here, maybe it'll write a little bit better. Stick with this one. One possibility could maybe be, we can take 10 times negative 1, which would not, we could take negative 10 and negative 1, which would give me positive 10. But if we take those same numbers and then do negative 10 minus 1, so we're adding, or in this case subtracting the same thing, you're going to get negative 11. So that doesn't work. It does multiply to 10, but it doesn't add to what I'm expecting is negative 7. What else can we try that's going to multiply to positive 10? Well, we can try 5 and 2 is of course 10. And then those same numbers would add to 5 plus 2, which is positive 7. So we're close. We got positive 7, but we're expecting negative 7. But if you remember, negative and negative is positive, so the change we could make is to do negative 5 times negative 2, and that's going to also give us positive 10. But then when we subtract negative 5 minus 2, that will give us negative 7. So those are the factors that are going to work to do both things. So the same two numbers do both things. So that means the factored form, the factors of x squared minus 7x plus 10, is going to be x minus 5, because minus 5 is one of our factors, and it's going to be x minus 2, that's our other factor. So this is our factored form, and we're looking for our solutions. In other words, our solutions are what value of x would give us 0 in both of these terms. So in this case, you could say 5 would be a solution because 5 minus 5 is 0. I could also show it this way. I can say x minus 5 is equal to 0. What would give us 0? By going plus 5. So 5 is one of the solutions. And then the other solution is what would give us 0 here. What minus 2 is 0. So the other solution is going to be positive 2. And if I went back to the step here where I plugged in numbers and saw, well, would it give me 0? I know that positive 5 and positive 2 would both work to make this statement equal to 0. Alright, so I think we could use one more example. So in this case, I want to solve what would give me 0 if I have x squared plus x minus 30. So factors of c, factors is multiply. What's going to multiply to give me negative 30? And at the same time, what's going to add to give me, in this case it says plus x, what's the coefficient in front? The b value here is 1. So if it's just x, you can just assume that the number in front is 1. So what's going to multiply to negative 30 and also add to positive 1? So one thing I can think of is maybe positive 15 times negative 2. That's negative 30. But if I do 15 minus 2, that's 13 and not 1. So those factors won't work. What else can I take? I can take a couple of different ones, but I know the ones that will work is 6 and 5. Except one of them has to be negative. So since I have negative 30 and I want to add to have something that's positive 1, I'm thinking which one should be negative. And I should multiply by negative 5. So 6 times negative 5 is negative 30. And then if I do 6 minus 5, I get plus 1, which is what I wanted. If I said negative 6 and positive 5, I'd still get negative 30. But then when I added negative 6 plus 5, I'd end up with negative 1, which is not the same thing as positive 1. So my factors here are going to be x plus 6 and x minus 5. Those are going to be the numbers that this trinomial can break down into. And then we can consider our solutions. So what would make this part 0? What plus 6 gives me 0? In this case, negative 6. And what minus 5 is 0? Well, 5 minus 5 is 0. So my two solutions are going to be negative 6 and positive 5. So I wanted to also show you, in some cases, in all of the practice problems, this will work. We'll run into this problem later. But in some cases, this strategy is not going to work. So something like x squared plus 2x minus 5, I'll make my t-chart. And that's how you guys can set up your work in this area. So I'm looking for what multiplies to negative 5 and at the same time adds to the middle term, which is positive 2. So you're always looking for what adds to C, what multiplies to C adds to B. So I could say negative 5 times 1, that's negative 5. But negative 5 plus 1 is going to give me negative 4, so that won't work. I can try 1 times negative 5, that's also negative 5, but then 1 minus 5 is negative 4 as well. Negative 5 plus 1 is negative 4. Negative 1 minus 5 is negative 4 as well, so that doesn't work as well. And those are really the only factors that gives me negative 5. So in this case, you can't do this one by factoring. So we'll need another solution that we'll learn about later. Alright, so for the practice, there's some instructions here. What I'm looking for is I have a Desmos activity called solving quadratic equations by factoring when a is equal to 1. You're going to go to slide 3. It should be in your Desmos classroom already. You're going to go to slide 3 and you're going to see something like this. And so this is what you're solving for each one, and I'll just walk through one more time with an example. I'm going to do the first one, and also going to give you a way to check your work, because when you put in your factored form, it should match one of the graphs. It's a bit of a mess here, but it should give you a resource to kind of check yourself. So we'll take this first one, which is x squared minus x minus 12. So we'll copy it down. Minus x minus 12 equal to 0. And then we'll, just like we learned, we're going to set up a t-chart. And you're looking to multiply, my multiplication symbol, to the last term, which is negative 12. And you want to add to the middle term, and since it says minus x, remember you're looking to add, in this case you're going to subtract the terms to give you negative 1. So what can multiply to give you negative 12 and add to give you negative 1? Well, we can have maybe negative 3 times 4. That's negative 12. Kind of a little bit cramped in here, but negative 3 times 4 is negative 12. And then we can have negative 3 plus 4. Negative 3 plus 4 is positive 1, not negative 1. So that combination won't work. But if we take positive 4, if we take negative 4 and multiply that by positive 3, we still get negative 12. But then negative 4 plus 3 is going to give us negative 1. So that's the combination we're looking for, which means our factors, I'm going to say F for factors, is going to be x minus 4 and x plus 3. X minus 4 and x plus 3. But remember, our goal, the ultimate goal, is to find the solutions. What values of x would give us 0? So I'm going to say S for the solutions. And in this case, what minus 4 is 0? Zero product property from the last lesson. So 4 minus 4 is 0. That's one of our solutions. And then the other solution is x plus 3. So negative 3 plus positive 3 is going to be 0. And so that's the solution. So let's go back to Desmos. We won't put the solutions in, but we're going to put in the factored form, x minus 4, x minus 4, close parenthesis, and x plus 3. And you could see, if you kind of look closely, doesn't let you zoom, but if you look closely, you'll see that this graph, the solid graph, is actually over another dotted graph. That's how you know that this does correctly match this form as well. So what you guys are going to do is just kind of go through, factor it on your paper, find the solutions, and then check your solutions in Desmos. If you have any questions or comments, or want to talk a little bit more closely about this, feel free to hop on to office hours and we can go over a couple more examples. Thanks, and I will see you next time.